we have enough time to do this. So this should be recording what's on the screen. So again, we're going to be modeling this problem, which is 1,000, 200 in height, and 400 in width. So this is a wind box where they have removed this panel over here. All right, so let's come over here. Let me just create a folder over here. So what's this one? What is it? This one, example 5? This is example 5. All right, so you come over here, open FEMAP. So I think I'm recording. Yes, I think I'm recording. You sure? Yep. So we are here. So, all right, so let's try to create let's just create points. Might not be the fastest thing, but so let's see. All right, so let's see, we start at, let's do the sentence. I'm going to do minus, what's the depth of this one? 200. So let's do first the lower one. 200 is 400, and let's do minus 200 over here. So basically it's going to take us what? To the lower flange on the left. So we have 1 point at 0. Then you leave the same thing, but you put x 500. And then the same thing over here with the x 1000. So units are in millimeters. Okay, so we did the bottom one. Now let's do the top one. So let's change this one to positive 100. And we start on the reverse, so we start 1000. Let's do here the 500. And let's do here the 0. Okay, so now we need to go to the other side. So that means we need to go to the positive 200. And basically the same thing. 0. 500, 1000, and now what is the last one we need to do? The minus 100, so we start by the 1000, 500, and 0. And I guess cancel. So now do Control A, and maybe so click the middle, on the middle button in the mouse. So I think that's about correct, no? This is the middle point, so this is like the origin. So, all right, so let's try to do surfaces. So let's go to geometry, surface, corners, and maybe here go to method and select on points. Okay, so maybe let's start by the side panel. So let's take this one. So what I do is I select this one, enter, select this one, enter, select this one, enter, select this one, enter. So this is one of the side panels. So I do now the other side. So the continuation, this one, this one, this one, and this one. So it looks about correct. Now do the other side, this one, that one, that one, that one. And probably now can finish this up, this one, and this one. Okay, so this will be what we saw at the beginning, the element that will be carrying what? The vertical load, no? So let's keep doing this, maybe select, let's do the middle one, this one, this one, this one, this one. Let's do the one at the end. Okay, now you can incline this a little bit, whatever you want. So now let's close this. Let's start at the bottom. So we close that part of the wind box. Now let's do the top part. So that's it. And then here we only need the bottom one because they say the top panel has been removed. And click OK or cancel. So I think this is the win box of the problem, okay? Did you all get it?
What if we accidentally put a surface in and we need to remove it?
What? Sorry, say that again?
What if we accidentally put a surface in and we need to remove it?
I think you can go to delete over here on top. Delete, I guess, geometry, surface, select that surface and delete it. It should not matter. I think we can, or otherwise I think you can unselect it here from the geometry, all the different surfaces we created. All right, so this is the geometry. Now we need to create the final model. So if you want, on the left tree over here, Info, open it, and let's go to Material, New. Really, the material used, it doesn't matter for this because we are not trying to calculate the formation. Still going to put the properties of the aluminum, which is, what, 17 to the 9. We work in millimeters, but it's not going to matter. Even if you put 1, it's going to work out. But here 0.3. And that should be enough. I mean, if you want on this one, put 40. No, don't put anything. You don't need to put it. And click OK. Cancel, you open the material property, make sure you double click on it so now it's highlighted. Now you go to properties. You can do this from the top menu as well, but I'm more used to do it on that side. I mean, I haven't used this program in 2 or 3 years, but this is the way I used to do it. So here you right click, select property new, as we did. So we need to select 2 different types of properties. So you go to element property type. So since we did the panels, what is the property we need to select? Shear panels. Here you can put the thickness. Since they don't give us thickness, I'll put 1. And then over here, I don't know, I always put these values here, which is 1 to the minus 4. And you put that. If you just put it on the top 2, it works, but I like to put it everywhere. So this would be the shear panels. Again, you can put titles and everything, but I mean, you need to start doing those things if you start doing very complicated models, no? But these models are pretty simple. So okay. And now we need to select another property that will model what? The flanges, no? So you come over here, road, on the left-hand corner. You click OK. And just for simplicity, just put the area to be 1. That way, the force will be equal to the area. Okay, in this program, we don't know what are the area, so we put 1, you click OK. So now cancel, and when you open here on the left-hand side the property, you should see those 2 properties being selected. Okay? So now we're first going to mesh the surfaces. So go to mesh, mesh control, and you have different options, but let's just go for the simplest one. That will be size on surface. Since you can select all the surfaces, I guess you can just say select all. Okay. And let's just make something simple. So this is 500, 500. I just take randomly 100, okay? Take 50 if you want, 250, whatever you want. I take 100. I think 100 is good. That way it gives you 2 elements on the thickness. All right, you click cancel. Now we're going to actually, so this was to define the size of the mesh. Now we're going to actually go into mesh. So you go to mesh, geometry, surface, and if you want, you can select 1 by 1, but let's do select all, and OK. Now make sure you select over here the shear property. This is the property you're going to be using, and you click OK. So now you should have the elements. All right, let's see if you can right click here on property, and so you right click, choose a color. This one is blue on blue. I'm not crazy about it. So I'm not crazy about this one either, but that green color. But that's generally the color I don't know if you have seen the aircraft before they paint the outside. It's aluminum, and then this is the anti-corrosion paint they used to put on top. It kind of has that color. So, okay, so why is not doing that color? Okay, go here to custom tools. Again, this is just not needed for the model. This is just to make it look better. Element update. Color elements to match property. And it became red. Okay, I don't know why it didn't do it automatically. It should do it automatically. So again, now we need to model what? We need to model the flanges and the rods to which the panels are attached, no? So go over here, we can do mesh, geometry, curve, and let's try to select, let's start from this end, from the bottom, so we select this one over here, the bottom. Let's select the top. I do the other side. Now let's do the root over here. So this one, this one, this one. The middle panel, this one, that one, and the one at the tip. So this one, that one, and that one. So hopefully I haven't missed a single one, but we'll find out. So you click OK. And now make sure you use here the road property and you click OK. Alright, so over here, maybe to check your model, go over here where you see the properties, shear and road. Click on shear so you can eliminate these ones. And click on road. Oh, it's not showing anything. So let's see, I'm going to do this. You see that little cube over there? Right on top. If you open it, you can say thickness cross section. Click on it. I should do a little cross section over here. But again, I mean, I think they're there. I see nodes everywhere, no? Make sure you have nodes everywhere, okay? Or if you want to make sure, if you want, you can come to the geometry here and eliminate the geometry. Okay, if you want, let's do it this way. So this way you see this will be the rod elements. This will be with both of them, and this will be just the shear elements. So I think that's okay. Okay, again, this will be only the rod elements. All right, so now what do we need to do next? We need to make sure that we're going to connect those two different type of elements together, no? So we mesh differently, so that means each one is going to have a different node. So we go to Tools, check, I know we have done this together, okay, on previous models. Check, coincident nodes. You go to select all, okay, okay again, or click preview. So basically, you should see that you should have all these coincident nodes, which makes sense, okay? And you can click done. And I guess, okay, again. So basically, this is our model, so of the structure. Now we need to do two things. So first thing we're going to do is to create the boundary condition. So model, since I eliminated the geometry, we're probably going to have to do it differently than I had in mind. Constraint. Since we don't have curve or surfaces, maybe just go here to nodal. And if you want, you can tag something or not, but let's just say here fix. or clamp. If you don't type anything, it's fine. Okay? And now make sure you select, oops, are there nodes visible here? There are no nodes over here, so. Okay, so you see, it did not let us do anything here because we cannot see the nodes, so do cancel. Why there's no nodes over here? I guess it has to do with the geometry. Just reactivate all the geometry.
Neither is your shear or web fragmentation selected.
They show up here again. I don't know why. Strange. All right, now they show up. When you reactivate the geometry, you see those little dots over here, green dots, those are the nodes. So let's do again this stuff. So model, constraint, nodal, and now you can select them, or you could do now on the curve, but just select the nodes which are close to the wall. Make sure you don't select any interior one. So even if you need to move the figure to make sure. So it's only the one that will be attached to the wall. You click OK. And now just click Fix. Basically means that this one will be resistant X, Y, and Z deformation, but also all the rotation of the moments Rx, Ry, Rz. Okay, and you should have 1, 2, 3, 4, 5, 6 showing up. Okay. So basically this is our model over here. So let's save this. File, save as, desktop. So solve this one as model. So basically this is our basic model. And now just save another one as model VY only, okay? That way we're just gonna study the first case that we did in our problem, which is to put the VY force. And okay. So now we need to apply that force. So something we can do is again model load, and let's do nodal again. If you want to put a title, but if you want VY, what's the value for VY? 2000 newtons or 2000 is enough. Okay, and now you go and select, make sure you select just that node over here and non-interior one. Okay, I'll make sure it's that one. Okay, now I see it. So that one over here. Okay, and once you get over here, we apply a force in what direction? If you look here at the current system, will be on the Y. So you put over here 2000. And you click OK. So basically double check that the force is just at that node, is over here, is 2000.
What node did you put it on again?
And the middle one of this at the end surface.
Alright.
FPS cyclomically shows a different number of nodes, I think, right?
If you did a different sizing,
Yeah.
size, you say? I mean, as long as it's located there. I mean, what size did you select it?
150, I think.
150?
Yeah.
So maybe that's a problem because on
Yeah.
the high that's 200, no?
So I'm thinking.
I mean, let me do something, okay? Let me stop over here the recording for a second. What I'm gonna do is that I email you, I put somewhere you can reach this model, okay?
Okay. So
Okay.
15 from there.
Let me just post this. Okay, so here we are. So just, I always like to do this. It's not needed, but it's a habit. File, rebuild. Basically, it's like if you did, if you went backwards many times, you're just gonna reset the whole code. So you say yes. Now save this one. And now, again, you can do that from the tree, which I like to do it from the tree. You can come here. When you go here to the analysis, you can right click Otherwise, you can click here the little two wheels here and analyze model, but I like to do it from here. The analysis, you right click, you say manage. If I go too fast, stop me, okay? It's a matter to do it together. So they say there's no analysis, so you do a new analysis. You click on new. You want to put a title, you can put a title if you want. If you want, say, Nastran VY equal 2000, okay? I'm still going to do two different models. You can put everything in one, but I already do different models. So static, you can click OK. And here, once you get here, you can go and click Analyze. And hopefully, it will run it. Okay, sometimes you get missed errors more often than what you think, but so here is saying that the Nastran is finished. Let me see if we put some results. Yes. So to close this one, I just click the little cross here. Now you can open here the results, or you don't have to, but I just want to make sure they are there. And you see this will be analysis, whatever. So we are here. Now what do we do? F5. Deform and contour data. We want to look, let's first look at the shear. So I don't know why they don't have shear flow. Here they do shear pattern max stress, which is 6019. I think that's the one we use. Yeah, that's the only thing I can see. Select that one and click OK. And then select in that window here criteria. Didn't we have shear flow in the other options? You know, they saw different Nastrans that I don't remember, so click OK. And basically that should give you the values, which you see are what? Are 5 on the side, which is what we obtained now. All right, and then they should be about 0, the top, there are small values. Everywhere else, no? Okay, so maybe something we didn't put on the derivation is what? Is that it's also going to be 5 over here, no? We did this one because this load will be carried by this one, but we can see that at the end. Okay, if you want over here, I think we have done that before, but I think you can leave it this way. It's fine. All right. So now, if you want, what we can do is this. Come over here up. Open the properties. Unselect the shear. So all this stuff should disappear. And if you want, let us create a group. So group. Right click. New. And let's call that one flanges or sparse. I think sparse. I'm going to call distance. Sparse. Okay. And then I think we analyze all these parts over here. So you go to group over here on top, on the top menu. Group elements. ID. And then here you can go and select one by one, but I think it will be fast if you go to method on curve. And let's just select the flanges with it. So like the top one here, the bottom one here, and then the same thing on the other side. And you click OK. So if you open the tree over here, you can right click on sparse. And you can say, just click on activate. So obviously you should not see anything. Okay? Now if you want, you can remove actually all those surfaces. All right? If you want to remove all those surfaces now, I don't think they're helping at all. Just remove them. It might help for the visualization. So basically this will be your whole model without the shear panels on your group. okay, because there is no shear panel, it's just the sparks. So now you go F5 again, deform and contour data. Instead of the shear, we're going to go and select road axial force, which is 3036. Select that one. You click OK. And here, instead of criteria, go and select beam diagram and OK. So basically, if you also want to remove these ones over here, the boundary conditions, you can go on top of the tree. So this is the load, and you can click on this one. You see on the top, you click that one, they will disappear. You double click, they will show up. But basically, this was the distribution we had. No, we say the top will be what? In compression, the bottom one will be in tension, no? And we did a calculation, I think we're going from 0 at the free end to 5,000 at the root. So obviously we don't get here 5,000. Why? I think we already talked about this, no? Number of elements, because here what it's giving you is the average between this node and this node, no?
What's a good number of elements to make?
I mean, depends on how accurate you want to be. I mean,
Can you make too many?
if you get too many, it's going to take longer, and then it's going to be harder to read. But for this stuff, it will be, yeah, it will be more accurate. Okay? Remember something, guys, is that when you design something, there are too many variables to say that, you know, that you're going to be exactly correct. What's important is that you are sure of what you have done by hand correspond to what you are doing with the final element. Okay? So that's my goal. Okay, if it's not perfect, it's fine. I just want to know that to double check what I've done. Okay, and if you want here, you see there's nothing in the middle ones. We could go and check on these ones over here, but we didn't do it. Okay. So, all right. So if you come here, you can say show full model, and then you can reactivate the shear panels, so you won't see anything, but they are there. Okay, so basically, I think the results obtained by the final element so far matches what we found by hand, no? Okay? So let's just save this model. Close it. And go and reopen the one we just called model. This one. Okay, and now let's just say save this one, file, save as, and call this one model T for torque only. All right, and you click save. Okay, now I think it's going to give it's not going to give good results, but let's try because maybe it works. And if it doesn't work, I'll show you the way I would really do it, but I don't want to complicate if it's going to work on the simplest way. So now what do we need to do? We need to apply a torque right in the middle, no? So we do the same thing, model, load, on the node. If you want, just call it torque, which is equal to how much? 1,000 newtons meters. Okay, so remember this is millimeters, so okay. I don't think it's going to work, but maybe it's going to work. So select this one, the node in the middle, and now you click OK. And so what do we need to insert now? Is it a force? No, it's a moment. So you can go on the left tree over here and click on moment. The moment will be in what direction? Look here, the current system. about the x, and the value is 1,000, but that's Newton meters, and we did the model in millimeters. So what do we need to do? Multiply by another 1,000, no? Okay? So you click OK, cancel. So file, I like to do the rebuild. Yes. Save it. And let's run it and see what happens. I don't think it should give good results, but maybe it does. So you go to Analyze again, right click, Manage, New. This time I'm not going to put any title or anything. I'm going to click OK, and then I'm just going to click Analyze. Okay, and once you see on the left-hand side say Finish, you close this one, and here you make sure that it created some results. They are right here. And again, F5. Let's select now the criteria, the form, and let's look for the shear. Because I think that's the only thing we started to do, the shear, panel, max shear, or the average. I think either one should work. Okay, okay. So it's giving 0. Which I was kind of expecting that, okay? I'll tell you now why, okay? It's because basically the shear panels, they need to be deformed. And if you put in the middle, this is not being deformed. Let's see. Let's first try the other way. Hopefully it would work. So over here, if you want all results, just click on it and delete it. That way we erase that stuff. Now go to, I think that's going to be the easiest way to do, delete, go on top, delete, model, and then just say load set, select all, there's only one, okay, okay, that way everything that we did for the loading is deleted. Okay, what's happening is this, what I think is happening is this, is that if this is the panel, if I apply the load over here, the only thing this is having the tendency is that it's just showing that this is moving by itself and it's not moving the whole panel. Okay, so what I'm going to do is that I'm going to attach, I'm going to take the nodes at the corners. I'll probably just need the one at the corners. If you want, we can take the other ones. Put them all in the middle and then apply the torque. So when it turns, it will be turning the whole cross section at the same time, no? Does that make sense or no? Okay, right now it's like spinning in the middle, like not doing anything. Because this is not being really, doesn't understand that all these elements are being attached. So, all right, how do you do that? You can do it by hand, but I think we can trick this a little bit. So, you want to just use the corner ones? Let's just use the corner ones. Let's see. So how can we do this? I think if you go to Custom Tools, Meshing, there you go. Before, you have to do this by hand, but now on the new versions, I think they have here, go at the bottom, Spider Nodes. Select Spider Nodes. And now, you want to select just the corner, or you want to all of them, basically? I mean, let's do all of them. So, just go from the, yeah, let's go from here, select just the ones on the edge. So you go all around. Make sure you don't select an internal one. So I went all around. And now, what's going to happen? If you click OK, you see basically what it's doing is connecting all those lines over here to the middle one, and you click Cancel. Did it do the corner one? Okay, I didn't do, okay, didn't want to do the side ones. But can you kind of see what happened over there? So if you go here now to, hopefully if you go to model, properties, okay, why? No, it's not a property, elements, by type, you should see 3 of them. So if I deactivate the roads and these ones, you should see only this element, okay? The one we created. You see what it's doing? It's connecting other nodes over there. Why do we still have the surface again? Oh, it doesn't matter. Okay, so now guys, this created a node over there. So it's probably going to be the highest number. So, I mean, yeah, let's just do it. There's a different way to do this, but now go to model, load, not all, and since we deleted the one before, we need to recreate this one, so let's just say torque. Just gonna call it torque this time. Okay? And now when you go here, you're probably gonna be able to select 2 nodes. So we have 98 and 101. What do we have 98 and 101? 98 is the one that corresponded to the initial one, no? Which is the way we tried to do it before, it didn't work. So the new node created is what? 101, the latest one, I'm assuming. So click on 98 and delete it. So to make sure we put the load at the center load created by this element, that being attached. And you click OK. Now we can apply the moment about X. That should be 1000 times 1000, or 1 to the 6. And click OK. So now cancel. File, you don't have to do this, but I like to do it. Rebuild. Yes. And run it. So you go to the tree, you can close it, the different stuff. You go to analyze, you already have the analysis from before. You can right click on it and just say analyze. Go to manage. Click on manage. I want to check something first. So it's this one. You don't have to do this, but I want to check something to edit. Since we changed, I want to make sure that it's using the correct load at the end. You don't have to do this, okay? Okay, it's correcting the load torque. That's the only thing I wanted to check, that this was there. Okay, and now just click analyze. And if that doesn't work, I don't know. So finish. Again, you can go to the results. F5. Everything should be selected already. 0 again.
Mine worked for some reason.
Yours work?
Yeah, mine worked.
Okay. So you see something, sometimes those things happen. What about the other people? Is it working, or did you get zeros as well? It's working? Okay, good. So, okay, so let me just delete this one. I'm not going to change anything. I'm just going to delete the model. Okay. Oh, hold on 1 second. Let me see if that, no, that should not change anything. I don't think there should be any coincident nodes. Just the middle one, but I'm not going to make it coincident. Yeah, I don't want that one to be coincident. Okay, so let me see if it's just the run. Analyze, manage, new. Okay, probably not, but analyze. Yeah, those things happen with software. Things happen, you don't know why. So results, still zeros. So basically, still not wanting to rotate. I mean, is it working for the rest of the class? Am I the only one for who is not working, or is it not working for somebody else?
Mine's not working.
No, yours is not working. What about the other people?
Mine's not working, but like I think I messed up in one of
Mine's definitely working.
Is it the criteria just needs to go to?
All right, let me stop this for a second, the recording, and try to resume. So, since we had an issue, I just went back to the initial model that we saved. That was like the foundation for both of them. So we have it over here, and basically, I think the error is about the node number. So now what we're going to do is again recreate the mesh over here. So you go to Custom Tools, Meshing, Spider Nodes, and this time I'm just going to select the four corner. You can select the other ones, but for sake of simplicity, we just select the corner ones, and you click OK. And cancel. And now what we're going to do is that go back to the left tree over here, go to Elements by Type, and just deactivate the shear panels and the rods, meaning you only have left the one we just created. Okay? And if you want, you can remove the surfaces at the same thing, but you should have the cross over there. So now we're going to go to Model, Load, and Nodal. Okay, and before, I don't know why it was not 101, just type torque equal to 1000. Okay, and now make sure you select this node over here, the one in the middle. Should be the only one. With the four corners, should be the only one. And you see before was 101, now it's 55, so I think that was a mistake. It was selecting some other nodes that probably wasn't attached to that rigid element. So you click OK. And now you go to the moments, and when you have the MX, you type 1000 times 1000 and click OK. And cancel. If you want, you can reactivate all the different elements you have and go to File, Save As, Model T Only, Save, and Yes. Go down to the tree, right click on Analysis, Manage, New, OK, and Analyze. I mean, this is the third model that you do, no? Or that we do in class. So by now, you start getting used to this. So this is finished. That's pretty quick. F5, criteria, and the shear panel mass, which is 6019. I think now it should be okay, no? Yeah. Okay, so we didn't finish this part of the problem, but basically now what do we have is that I think the other day, what did we do? We did Bay 1, no? What is Bay 1 is this area here, which is in red. All right? And I think that's where we stop. So let me go here. I think that's where we stop. So basically, let's go back to this problem over here. we found -5 for those shear forces. Okay, which basically, if you go to the FEMAP over here, file open VY only. Oh, okay. F5. Oops. What did I put? F5 is F5. Form. I'll go very quick. Basically, you see what we have: 5 over here, 5 over here, 5 over here. I mean 4.999, 4.997. Close enough, no? Okay, which is the same thing that we found. All right, so we found here the 5 on this panel, and actually, yes, it should be the same on this panel over here. So we did now the bay 2. We found 5. Then we did the loads on those panels, and we found that we're going to tension, compression, both and bottom. Then we move to this was the second way to do it. We get the same results. Now the torque only, and we were here, we were at bay 1, okay, at T equal to Z. So if you want, let me write over here. Bay 1. Oops, not a good idea. So we did this, we did the torque. So we did these calculations, and basically, what did we find for the torque? Equal to 12.5. All right, which one would be 12.5? This was at the wall, the sides over here. All right, so if we go at the wall, you go to the FEMAP. It's not this model, it's the other one. You see that it's 12.5 at the walls over here. Okay? So now we need to move to the bay number 2, which is this one. So this one's a bit more complicated because you have the middle bay in the middle and the top and bottom panel. But again, it's all about statics and then to do good sketches. All right, so we close over here. We are over here. All right, so now we move to bay 2. So let me see how can I do this figure. All right, so let's say this is bay 2 over here. Again, the most difficult part for me is always to do the figures. Okay, so this is bay 2. So basically now we are at, this is here 500. And this will be here 1,000. Okay, so from the previous part, what did we find for being P, the force along the stringer, along the spar? It was the value of P, no? And P we found to be equal to 3,125. So this was on the top spar. You see between 1 and 3,000. In the middle is 0, but what is the value of 500 is 3,125. So basically, if we needed to plot this, what would that mean is that you will have the load P over here. And then, so now we're going to have a problem. So now we're going to have this, and this is the bay 2. Now we're going to have here shears. I do it in that direction. You can do it differently if you want. So how did we call the one on the previous page? We call it Q bar sub 2, no? Okay, so let's call this one then Q bar sub 1. And then over here we're going to have another one. Q bar sub 3. Okay? And we know this is $200, and here this is $400. Okay, and this is over here the, okay, so basically we need to do this figure in order to find one equation relating Q bar 1 and Q bar 2. So let me just redo another figure. I like figures. We could do it from the top one, but I'd rather do it that way. So we have, I'm just looking here at the top, so this will be P. Over here. So if we look at P over here, this will be Q bar 2 and this will be Q bar 3. Do you see what I've done or not? Okay. Okay, so this is 500. Q bar 1, you're right. 500, 1000. Oh, I forgot today my, all right, Q bar 1. Q bar 1. Okay, so if we do summation of forces on this element, I'm not going to put in what direction. What should be really the direction? Didn't we select the coordinate system before on the other problems? No. I think it's the Z, no, but because the coordinate system I think is Y, X, and Z, no? Okay. So if you want, put the Z over here, but it's not needed if you want. Okay, let's put it if you want, Z. But what's more important is that you just do it from the figure. So if you do it from the figure, what do you get then? You get P positive. So this is the top spar. That's where we are doing it. So the top spar. We get P, then what is the length of this one? Would be 500, no? So if you want minus 500 Q bar 2, Q bar 1, insist with Q bar 2, Q bar 1, plus 500 Q bar 3. okay, equal to 0. And from the previous problem, what do we know? That P is equal to 3,125. I think I'm pretty sure, but let's just double check. Yeah, 3,125. So basically, we move ahead. Oops. I think I can stop the recording for this part.